Okay, this one is about multiplying and dividing rational expressions. So, before we do this, rational expressions mean fractional expressions. So, I want to just remind you how to multiply and divide fractions. If you have some fraction here, a over b times c over d. This is really the easiest thing that we get to do with fractions. You just multiply the numerators and multiply the denominators. This is equal to a times c over b times d. That's it. If you're dividing fractions, a over b divided by c over d, this is what we call keep, change, flip. So you would keep the first fraction, a over b. You change the operation from division to multiplication times the reciprocal, d over c. So you keep the first fraction, you change the operation to multiplication, and you flip or take the reciprocal of the second fraction, and this is a times d over b times c. So that's what we're going to be practicing. However, if we can cancel things, common factors along the way, we will do that. For instance, if we were going to multiply x squared, 3x squared over 4y times 16y over 12, let's see. Instead of just multiplying straight across, I'm going to cancel as I go because these are all being multiplied. I'm allowed to do that. Anything in the denominator, I'm going to sneeze. I'm practicing healthy sneezing into my clothes so I don't spread the virus. Anyway, anything in the denominator that's in common with anything in the numerator can cancel out as long as it's being multiplied. Everybody's here being multiplied. 3 times x squared times 16 times y over 4 times y times 12. We can cancel. So let's see here. I see 4 can go into 16 4 times. 4 goes into 4 once, into 16 4 times. Y can go into y 1 time. Oh, I have a 3 that can go into 12 4 times. Oh, I have a 4 that can go into 4 1 time. You are allowed to cancel like that. We'll be doing that along the way. And then I multiply 1 times x squared times 1 is just x squared over 1 times 1 is just x squared over 1. You would get the same thing if you multiplied 3 times x squared times 16 times y divided by 4 times 12 times y, only you have a much bigger number. So I'm not going to do that. I'm going to factor along the way and then cancel as I go. All right, let's begin. Here, number 1, we have x squared minus 25 over x squared minus 3x plus 10 times x plus 2 over x. Factor anything you can factor. So the numerator will factor into x plus 5 over x minus 5. The denominator here can factor into, let's see, I have a negative 10. I want two things to add up to be negative 3, negative 5, positive 2. This times this is this. This plus this is this. This will factor into x minus 5, x plus 2 times x plus 2 over x. So you can see that in order to simplify rational expressions, you have to be good at factoring. You have to be able to factor to do that. It's key to all of this. Now everybody's being multiplied, so I'm allowed to cancel. So let's see, what can I cancel? I see an x plus 2 and an x plus 2. One's in the denominator, one's in the numerator. Great. I see an x minus 5 and an x minus 5. One's in the numerator, one's in the denominator. Leaving me with x plus 5 over x. Remember, I cannot cancel this x with this x because these are not being multiplied. That's illegal. This is as best as I can do. All right, let's look down here. This is a division problem. Immediately, I will change it to keep, change, flip, and then factor so that I'm canceling where I should cancel. Many times if you factor first, you might forget to change this to multiplication and reciprocal, and you might start canceling things that you're not allowed to. So I think you should first change it to multiplication. So let's see. This is going to be keep. If you want to, okay, I'm just going to, m squared minus n squared over m plus n times m squared plus n times m over n. Keep, change, flip. Now factor, factor, factor. So this will be m plus n times m minus n, difference of squares, over m plus n. And if you want to put parentheses around there, sometimes I like to do that, it's fine. Factor out the greatest common factor here, that's how we can factor that. I can pull out an m, leaving me with m plus n all over m. Now, if ever you're like, oh, did I do that right? You don't have to wonder, you just check it. You multiply it back together. M times m is m squared, m times n is mn. So that's fine. Now, everybody's being multiplied, we can cancel whatever we see in common. M can go into m one times. M plus n can go into m plus n one time. That's everything we can do. We are left with m plus n times m minus n, or if you want to multiply it back together, you get m squared minus n squared. Now, here's a question sometimes students might ask, could I have canceled this m plus n with this m plus n? Yes, you could. If you did that, though, this one would still be there, and you'll still get the same answer right there. Okay, how about this guy? Factor, 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 factor. It's already being multiplied, so go ahead. This right here, x squared plus 6x plus 8, will factor into x plus 4 times x plus 2. I'm not really taking time in this video to go through how the mechanics of factoring. I'm assuming you know how to factor. X squared plus x minus 20 will factor into x plus 5 times x minus 4. Let's see, x squared, 5 minus 4, negative 20, times, factor this guy, x plus 5x minus 3, x squared plus 2x, okay, minus, that's okay. This one will factor into x plus, what's it going to be, 4 times x plus 4, x squared. 4 plus 4 is 8, 4 times 4 is 16. Okay, factor, 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 factor. Who's in common? I see an x plus 4 with an x plus 4. Okay, I see an x plus 5 with an x plus 5. Is there anything else? No, there's nothing else. So this is equal to x plus 2 times x minus 3 over x minus 4 times x plus 4. That, to me, is an acceptable answer, but if they want you to multiply it back together, you could do that as well. It would just be, this is also equal to x squared minus x minus 6 over x squared minus 16 would be if you multiply it back together. Okay, down here, division problem. Keep, change, flip. X plus 2 over 7 minus x times x squared minus 9x plus 14 divided by x squared minus 5x plus 6. Factor, factor, factor. There, we can't factor these. These are done. This is just x plus 2, 7 minus x, just like that. Okay, times. Let's see if we can factor these guys. Let's see, 14, I need two things to add up to be negative 9. It's positive, both of these will be negative. It's going to be negative 7 and negative 2. This times this is this, this plus this is this. So it's going to be x minus 7, x minus 2. I need 6 to add up to be negative 5, negative 3, negative 2. Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. This will be x minus 3x minus 2. All right, once everybody's factored, then you can cancel whatever's in common, numerator, denominator. Let's see here. I have an x minus 2 with an x minus 2. That goes in one time. I have a x minus 7 and a 7 minus x. Remember this guy? 1 doesn't come out, negative 1 comes out when these are flipped like this. So a negative 1 is going to come out, leaving us with, okay, x plus 2 times 1, okay, over this. We have an x plus 2 in the numerator. We have a negative, because of this negative 1, over x minus 3. This is one way you could write this. You could also write it as x plus 2 over 3 minus x. If you distribute the negative, that's another way. There are a couple of other correct ways you could write this as well, but that's basically multiplying and dividing rational expressions.